So let's see. I've taken these numbers from the Energy Book of Pakistan that is published by the Hydrocarbon Institute, and I believe these are 2019 figures. And if you see energy generation in Pakistan, they're dominated by the oil and the gas, essentially hydrocarbons, fuel-based energy production. And if you see the consumption of these energy resources, I believe you all understand domestic consumers and industrial consumers, but I want to highlight here is transport is the second largest energy consumer in Pakistan. And a lot of these resources, oil, gas, directly or indirectly are being consumed by the transport sector. I would also mention that, for example, in industry, if they're producing any electricity, they will be using generators, and generators are essentially they involve engine also. So same technology going into transportation may be used in industry also. And one more point that I want to mention, transportation systems are 20 to 30% efficient. So you can see 38% of the oil, if it is being used by transportation sector with this efficiency, how much of inefficiencies we have in the system. And we would like to avoid that in any case. Let's go a bit deeper into the transportation sector in Pakistan. So I've taken these figures from National Transport Research Center, NTRC. And essentially this shows the evolution of the vehicles on the road of Pakistan. So this change, percentage change with respect to the 2015, 16, and 2018 and 19. Essentially, we are looking at a 4 years change of vehicles on the road. So starting from motorcycle, scooter, and my understanding is they may involve Chingchi or motorcycle-based three-wheelers. We have seen 119% increase of these vehicles on the road. Motor cars, 22% increase since last 4 years. Taxis, 10%. Rickshaw, 13%. Buses, 10%. So other numbers are, I would say, yes, on the increasing trend, but this motorcycle or scooter, 119%. This is very much popular in Pakistan, and a single household may have multiple motorcycles also. Overall, we see there is a 62% increase of vehicles on the road. Now, another major contribution of this transportation sector is the pollution. And I believe we are coming across smog issues, pollution concerns in the cities now. And if you see the breakdown of nitro oxides, what is the contribution of transport sector? So 20% of the nitrogen oxides are being contributed by essentially the diesel vehicles. And my understanding is even in the industry, we have gensets, generators running. Perhaps they might be contributing nitrogen oxides or nitrogen pollution in Pakistan. When it comes to carbon dioxide, 44% of the pollution is contributed by transport sector. And due to the various factors that includes oil prices, urbanization, economic growth, population density, the contribution of transportation sector towards the CO2 emissions, carbon dioxide emissions, have increased from 16% to 28%. And I believe I have these figures from 2004 to 2014. By now, they may be more. As we see 119 or 62% increased vehicles on the road. So again, this transport sector is a major energy consumer and major contributor in the pollution. And that's why we are observing that government of Pakistan is issuing EV policy, Euro 5 standards. That they are realizing that transportation sector needs to be reinvented, or I would say evolved. It needs to be evolved in order to take care of the energy, resources, and the environment in Pakistan. So when I say a transportation sector is going through evolution, or it's in the phase of reinventing, there is a terminology being used which is called 3 revolutions in transportation. What are these 3 revolutions going on, and how will they influence the transportation sector or transportation landscape in future? So one of the revolutions going on around the world, and you'll see a major shift in the automotive systems, is because of the electrification. Other part is connectivity and automation, and the third is the shared mobility. These 3 revolutions will fundamentally change the mode of transportation landscape around the world. And each revolution has its own impact on the energy consumption and on the emissions control. We'll go through over these. But the point that I want to highlight here is, more or less, we are all aware of that any of these 3 revolutions is going on, and we have been experiencing partially these 3 revolutions. So let's try to understand what are the benefits envisioned based on these 3 revolutions. So the report that I'm citing starts from 2015, where they're looking at the kilometers traveled by the vehicle. What they're observing is BAU stands for business as usual. Nothing changes. What will happen? How many kilometers the vehicles will be traveling on the road? 2R means 2 revolutions: electrification and connectivity and automation. 3 revolution includes the shared mobility also. So by 2030, we do see increasing vehicle travel, kilometers, and by 2050, significantly, the vehicles will increase on the road. But if we are looking at the ride-sharing opportunities, we can bring the total kilometers traveled overall to a lesser value. If we are able to understand how many kilometers the vehicles are traveling around the world, emissions will go the same way. What we are observing, business as usual will have more contribution of pollution from the engine vehicles. And then if we introduce electrification and connectivity and automation, we bring it down to some extent. If there is ride sharing, we bring it down further. And if the trend continues until 2050, we see there is a significant reduction in the emissions also. And same is true for the energy consumption. 3 revolutions is what's being highlighted here. If all of the technologies are being used, we can bring down the energy and the pollution significantly. Now, let's try to enumerate the benefits of each revolution. Yes, electrification can help us emission reduction. It helps us to enhance the efficiency, better performance, energy security. Connectivity and automation helps us to enable cheaper travel. It's more productive use of the time. You get some information that can be used for safety and performance improvement also. And shared mobility essentially is the efficient use of urban space, improving traffic congestions, and improving the urban livability. Now, if I want to correlate the driving habits with these 3 revolutions, we are more or less practicing this individual to individual basis. What you will see in driving in neutral gear essentially is what electrification also recommends. Turning off the engine at red light, that's part of electrification. We minimize idling losses. Slowing down when you see the traffic light, essentially your eye is communicating with the traffic signal. So that's the connectivity. From radio connectivity, avoiding traffic lights where you know the information. There are some traffic lights that may create traffic jams, so let's avoid that. If you're sharing ride for office, which is very common in Pakistan, for schools, that's ride sharing, which is already going on in Pakistan for a long time. If you're preferring bike over car, essentially this is a downsizing of the engine, and you are consuming lesser fuel for the same mission. And the last, overfilling of the tank is nothing else than a jugaad. So essentially that doesn't help. And perhaps it is not good for the engine itself. Essentially, the emission system of the vehicle is being influenced if you overfill the tank. So it's not recommended. So these things, yes, you're using your fuel needle is not going down, but essentially this is not good for the vehicle health. So let's get back to the topic, 3 revolutions. Now, what are the opportunities? If you want to go behind these topics, there are so many opportunities coming out of these 3 revolutions. In electrification, component sizing, powertrain architecture, energy management, because you have multiple sources. So there are so many topics, battery life, safety and security of these components. We will be going through component sizing and architecture studies in the coming slides. But these are all open-ended questions or opportunities where researchers can go behind. Connectivity and automation brings eco-driving, which means that how do you enable less braking, yet keeping the vehicle safe and secure. Green wave means you always hit the green. How is it possible that you can always hit the green light always, so you don't have to wait on the traffic light? Congestion reduction and optimal routing. There are multiple ways of getting from point A to point B. What's the best way? That can connectivity. If you have, like, you are avoiding traffic lights or you are avoiding traffic jams, so that's the optimal routing part. Similarly, shared mobility, multimodal transportation. That means if somebody is going from home to work and they have to take, let's say, Thankyou or last mile or first mile vehicle, then get onto the metro. So there are multi-modes of traveling. So how do we sync up these multi-modes of transportation? That's multimodal transportation. Smart logistics and delivery, fleet management, ride sharing. Everybody's experiencing Uber and Careem, so that's going on these days. So these are all the opportunities that one can go behind. And the topics that I'm going behind in these are essentially related to controls, optimization, safety, and security. Before we get into the further analysis, I would like to highlight that we have to change our thought process when it comes to tool adaptation and analysis. We need to understand that engine, motor, or a battery of any component on the vehicle is influenced by the traffic. So we need to create simulation tools or our analysis tools that help us to understand the impact of traffic on engine, impact of eco-driving or less braking driving on motor or battery systems. So previously, we used to focus just on engine. Let's see how the engine behaves, irrespective of how the other vehicles would influence it. But this trend is evolving, and we need to focus more on system-wide analysis. Another thing is we would like to bring in more real-world scenarios, real-world information in order to understand the performance of the vehicle. So we need to have all of these information. If we can bring this information in such a way that the vehicle can comprehend it, we can certainly improve or enable the vehicle to improve its efficiency. Third thing that I would like to highlight is we are used to thinking of vehicle mileage in terms of a single-digit number, let's say 18 kilometers per liter or 12 kilometers per liter. Although we do understand that that's a distribution rather than a single number, because your driving habits, the traffic conditions influence the fuel economy of the vehicle, and instead of one number, we would like to have a distribution of the fuel economy which has some mean and some variance. So this plot is essentially showing that, okay, you have conventional vehicles where there is no hybridization. There will be a distribution of fuel economy, not just one number. If you have rule-based control, that's one strategy. It may have the other distribution. And these are several variants. Instead of looking at one number, we need to see the distribution. And on the other side, each technology, when it comes to sensing and connectivity, this will also influence the fuel economy in terms of its distribution, not as a single number. So this is something that we need to understand. MPC here stands for Model Predictive Control. So how you can move from if this is your conventional vehicle, there's no hybridization, and dynamic, DP stands for dynamic programming. This is the maximum or the most optimal solution you can get out of the powertrain. But this is hypothetical. You cannot achieve it in the real world. So this is my upper bound, this is my lower bound. So essentially, I would like to understand the distribution of fuel economies in between them. And we do understand that the automation, ADAS features, ADAS means advanced driver assist features, are constantly being added up to the vehicles these days. And it has been going on since 1980s. So these are some of the systems that are already being installed on the vehicle, and more are coming. So now with this three revolution, the challenge that we are going behind, energy and pollution, emissions essentially, and we are evolving our analysis approach. And these technologies are coming day by day, and they are available on the vehicle. Let's see how we can use them. Need of alternate powertrains. So what I want to highlight here is we all understand hydrocarbon fuels are contributing to emissions to the environment, and the prices are pretty volatile. I think everybody is experiencing these two concerns. That's why we need to shift to some other alternate powertrain. In this case, I will be discussing the electrified powertrain, but adapting those powertrains is not easy. We have batteries that are heavier and costlier. Charging infrastructure is not there. Customers are not ready to use it because it's a different driving experience. Fleets are reluctant to adapt because these electrified vehicles are expensive. And then one point that I want to highlight and go deeper into this is one solution doesn't fit all. If for a given mission, the powertrain is not optimized, it may behave worse in case of performance and emissions as compared to the conventional counterpart. So we need to design a very dedicated powertrain for a given mission.